Welcome to Start Studies Co. Today we are going to discuss electronics part 15 of class 11 ammeter shunts. I hope you will enjoy this video, but before getting started, I will also like you to subscribe to my channel and as well as like and share with your friends so that it will help me to create amazing videos for you guys. So let's get started now. We already know about ammeter and how we use them in a circuit. Ammeter is always used. It is always used in a series combination in a circuit. But what is a shunt ammeter? That is a quite good question which we need to solve it. Okay. Now what is a shunt and why it is combined with ammeter? Now you know when it provides its basic function is it is basically resistance same as ammeter. It is a resistance but it provides a very low one. Okay, so that means it will let the extra current pass through it. Okay, so shunt ammeter is used whenever we think there is a large portion of current which may harm the circuit or the ammeter or the meter in general base. Then we connect a shunt parallel with the ammeter. Okay, the shunt ammeter is always connected in parallel combination with the ammeter and it provides low resistance so that the as it is the low resistance path, so the extra current will pass through the shunt one. And how it will help? It will help to surpass the extra amount of or surge of current to pass through it. Okay. Now it can be inbuilt. The shunt can be inbuilt in the circuit or it can be added externally in the circuit. Both can happen. And we can also devise a procedure to add a shunt ammeter parallel to the ammeter one. Now next we will decide how to calculate how much of current will go through the shunt. That is very important aspect of this thing. So let's discuss that as well. Basically, whenever we are connecting a ammeter in series, it is always conducts small amount of current. You must understand that. So if it is conducting small amount of current or letting pass small amount of current, that means it is a high resistance path and it is always in series in the circuit. Now for any heavy current or surge of current which is coming at an instance, a shunt should be connected to the ammeter in parallel combination. So most of the current will pass through the shunt due to low resistance, as I have already told you. Now as the shunt is parallel to the ammeter, what will happen when there is a parallel combination of resistances? We know the voltage remains the same throughout the circuit as well as the parallel combination. So the voltage drop remains the same in shunt as well as in ammeter. So what will happen? So for that I will draw a diagram of a circuit so that we will get to know how the shunt will provide a safer path for the current to flow through. Now this is a shunt resistance I am making, which is of course this is also a voltage which we know of. This is V, this is I, and there is another ammeter here which is a very small current flowing thing, but it will show deflection anyhow. So it is let's say it is ammeter. I will name it as ammeter. This is the shunt and the resistance will be called as RSH with the suffix SH, and it is RM simply. The current flowing through it will be named as IM. As the current is getting divided at 2 points, this should be ISH in the ideal condition. Okay, let's think that there is no leakage of current or any surpass of current through the circuit. Then how we are going to decide how much of current will be ISH? Okay, so for calculating that, as the V is same, we know V equals to IR. Now for the shunt one, this would be ISH RSH, isn't it? I multiplied with R. Now for the ammeter one, it would be simply IM into RM. Now as V is in equal in both, I can equate these two. So I will simply write ISH RSH equals to IM RM. So if it is that, then I will be calculating RSH as IM RM divided by ISH. But I should be knowing what should be ISH. Then only I'll be able to calculate what is RSH. So this is equation number 1. But as we know, the current is getting divided into two parts, into shunt and ammeter. I can simply say ISH equals to total current minus the ammeter current, which we shall be knowing from the deflection in the ammeter. So this is the equation number 2. So if that is the case, I can combine RSH equals to IM RM divided by, I can just put the value of ISH as I minus IM. Okay, that is very easy. Now I will do one thing. I will bring RSH to the denominator and bring the denominator, that is I minus IM, to the other side. So that would be I minus IM equals to IM RM divided by RSH. Now again, what I will do, I will divide IM into this side. So that would give me I divided by IM minus 1 equals to RM by RSH. Now in the most important thing I am doing here is, in LHS I am bringing all the current terms, in RHS I am bringing all the resistances terms. So that will be very helpful for my purpose. But at the same time I am getting the formula that I divided by IM, both of them I know of. So I can simply add 1 plus RM by RSH, which will give me the, this one is one formula we should be remembering. So basically this formula is very important us to remember for shunt ammeter, because the ratio of I is to IM is called multiplying power of the shunt. Okay, I is to IM, or I divided by IM gives us the multiplying power of the shunt. So this is the third equation we are getting. I divided by IM, that is the ratio of the total current to the ammeter current, equals to 1 plus ratio of resistance of ammeter divided by shunt resistance. Now, how do we find the shunt resistance? That is also very easy to find. As we already deducted the formula, the ratio between I and IM is called multiplying unit or multiplying power of the shunt. That's why I can just place the RSH, and I can place the equation in the RSH one. RSH was IM RM divided by I minus IM. Okay. Now what I'm going to do, I will simply put it like RM, and this would be M minus 1. How so? Because if I am dividing in this portion, I am changing the color so that you will remember as an explanation. In here, IM RM divided by I minus IM, what I did, I simply divided IM in the numerator as well as in the denominator. Okay, so this is all equal. So now I cut out IM and IM here. Now here in the denominator it will be RM divided by I divided by IM minus, again it would be 1. So this I by IM ratio is called multiplying unit or multiplying power. So I denoted it as M only, so M minus 1 will be in the denominator for RSH. So this is another formula for RSH. If we know the resistance of the ammeter and multiplying power of the shunt ammeter, then we can find out the resistance of the shunt. So these are all formulas for shunt ammeter if you need them. And normally the shunt ammeter is made up of manganese or Constantan. Those all are alloys depending upon the nature of devices where we are working or putting the shunt. And also we should consider the temperature coefficient as well as the temperature endurance of the material given here, so that we will have a like suitable range of temperature endurance in the shunt circuit. So this is it for shunt ammeter. I hope you understood well. If you do have any doubt, please write in the comment section so that we can solve the problem or any doubt together. Take care, have a good day, and do not forget to subscribe my channel.